Okay, let's look at example 1 for subtopic 3.1. At a city park, a boy throws some bread into a pond. Two ducks of mass 4 kg each and a 9 kg goose is paddling rapidly towards the bread as shown in this figure here. The duck is swimming at 1.10 meter per second, whereas the goose is swimming at a speed of 1.3 meter per second. Now we have to determine the total momentum of all three birds. Okay, so firstly what I would suggest you to do is always extract the information given from the question. So the first information we obtained is the first duck punya speed, which is 1.1 meter per second, and then the speed of the second duck is equal as well, so we can just equal like this. And then we have the velocity of the goose, which is 1.3 meter per second, and mass of each ducks and goose. Okay, 4 kilos, and then mass of the goose is 9 kilos. Right, so that is the information we have. Now, what else should we do? We have to consider the direction of each bird. Okay, so this is let this be the bread. Okay, so we are seeing that the goose here is moving upwards, so we can draw the momentum of the goose is following the velocity direction of the velocity. So that's why I draw momentum of goose is going upwards sebab dia ikut velocity punya direction. Okay, now we have the duck. The second duck is moving to the right, hence the momentum is also going to the right. And then we have the first duck lagi, it is going down, so the momentum would also be going down. So this is the first duck. Okay, now after you do that, you can then find the magnitude of the linear momentum for all three birds lah. Okay, so let's do that. P momentum of duck 1 is mass times the velocity. So mass of duck 1 times velocity of duck 1, you will then get 4.4 kilogram meter per second. The duck 2, same thing, you'll get 4.4 as well. And then goose, mass of goose, velocity of goose, you'll get 11.7 kilogram meter per second. Okay, now we have to consider the total momentum. Okay, so do we add these three all together macam tu je? No, wrong. We cannot add this together and then get the total momentum. This is wrong. Why? Because we have to consider the direction. Okay, remember momentum is a vector, so we have to consider the direction. Positive ka, negative ka, the values. Okay, so how do we do that? Let's try and do in a table. We use a table, y component, x component. And then this one is for the first duck, second duck, goose, and then we have the total. Okay, total momentum for x component as well as y component. Okay, so for the x component of duck 1, so let's look at this diagram. For duck 1, we can see that the momentum is at the y component. So do we have an x component going to the right? No, because this is a 90 degree. Okay, so the x component for momentum of duck 1 is 0. And then y component, it is just PD1 lah. Momentum duck 1, which is 4.4 kilogram meter per second. And then let's look at duck 2. Duck 2 has only momentum at the x direction, it won't have any y direction punya momentum sebab this is a 90-degree angle. So at x component, it is 4.4 kilogram meter per second. Y component is 0. Okay. Now for goose pula. Goose punya, it is going up. Again, it does not have any x component, so x component is 0. For y component is 11.7. So is this just it? No, we have to consider the direction. Okay, so which one yang will be negative? Which of these values should be negative? Remember our convention, positive is going up, also going to the right. Going to the left means negative, going below is also considered as negative. Okay, so based on this one, we can see that momentum for duck 1, the y component should be negative. The rest of this should be positive lah. So this is the only value that should be negative. Okay, so this is negative. Okay. Okay, now we can then find the total momentum for each component. For x component, it is still 4.4. For y component, negative 4.4 plus 11.7 would equate to 7.3. Okay, so that is the total momentum for each component. Is this the end of it? No, we then have to find the magnitude of the momentum. So how do we find the magnitude? We can just use this. So momentum at x plus dengan momentum at y. Just substitute the values, you'll then get 8.52 kilogram meter per second. So that is the total momentum of the 3 birds. Now the direction pula. The direction, again, just use shift tangent, py over px. You'll then get the direction of the momentum to be 58.9 degree. Okay, so that is your example number 1. So what you should know is, from this question, you should know that momentum has direction, has both direction and magnitude. Lepas tu, we have to consider the direction for each component lah. Okay, kalau dia perlu resolve, kita perlu resolve dia. Alright, okay, so that is for example number 1.